Beg your pardon for the beginning. Obviously, in our today's experiment, we will be doing the test in the laboratory with the help of this particular testing of the aggregate, which is known as the shape test. Okay, so we will be going for the shape test of the aggregate. So we need to remember that shape test is obviously very much important test in terms of the aggregate testing, because on the basis of this test we will be going for the different kind of aggregate testing in the future. Okay, so we will start with the shape test at first. So first of all, it is known as the determination of flakiness and elongation index. Okay, now flakiness and elongation index, that means they are having some values, and that values will be expressed in terms of the percentage. So obviously we will try to understand flakiness and elongation index. Okay, now this flakiness index is the percentage by weight of aggregate whose least dimension is less than 0.6 times of the mean. Now what does this actually mean? It means that whenever we are going to take care of the aggregates, then there will be a batch of aggregate where different sizes of aggregates will be mixed together. Now among that particular batch, some of the aggregates will be having different sizes. So it is the percentage of weight. Obviously a small amount of aggregates will be there where the least dimension of those aggregates, obviously the thickness is the least dimension, is less than 0.6 times of the mean value. Okay, that mean value will be depending upon the different kind of aggregates. Okay, now that mean value multiplied by 0.6 will give you another value, and the aggregate's thickness must be less than that another value. Okay, that is calculated value from the multiplication of 0.6 and the mean value of the aggregates. Okay, and that is actually known as your flakiness index. Okay, now another definition is there, is the for the elongation index. It is the percentage of weight of aggregate whose greatest dimension is greater than 1.8 times of the mean. Remember, here we have mistakenly written as the least one, but it is the greatest dimension. Okay, so its greatest dimension should be greater than 1.8 times of the mean. Okay, so greatest dimension should be greater than 1.8 times of the mean, means that mean or average value will be again there, and it should be multiplied with 1.8, and the aggregate sizes in terms of the aggregate's length should be greater than that particular value, which will be calculated with the multiplication of 1.8 and the mean value of the aggregate. That should be called as the elongation index. Okay, now for this laboratory testing we are having with us Mr. Ajitesh Bhattacharya, senior technical assistant in the Department of Civil Engineering, Dr. Vishnu Engineering College. He will be guiding you to understand this particular test procedure. So for this testing we have different instruments. Okay, so those instruments are, one on your left, it is known as the thickness gauge, and this is your length gauge. This thickness gauge is used for the determination of flakiness index. Okay, now what we can see is that here some graduations are made and some openings are there. Obviously, some values are also written over here. So 25 to 20 is written over. This means the aggregate size will be between 25 to 20. Okay, and this opening size, however, is equals to the 0.6 into the average value of 25 and 20. Okay, so this is what the flakiness index tells us, and we are having that particular opening size as per the calculation. So the aggregates which will be passing through this particular opening will be known as the flaky materials, and which will be retained on this opening are known as the non-flaky materials. Okay, so similarly here the flakiness index is written over here. Okay, and here the elongation index is written. It is sometimes also called as the length gauge. So length gauge also is having this kind of graduation. Now along with this we need a set of sieves starting from 20 mm to 6.3 mm. Obviously 6.3 mm is the limiting value of the aggregate. The aggregate sizes below 6.3 should not be used for the testing. And here we have taken 2 kg of aggregate sample, okay, for the testing purpose. Remember, we have shown you the demonstration only, so that is why we are only taking this much of aggregates. Otherwise, you should be taking minimum of 5 kg of aggregate here. Okay, now we will take this aggregate into the sieves and will do the shaking of the sieves. Here I have done it manually. Definitely the manual process should not be used in most of the cases, but in some cases, as we are showing it you the demonstration of this lab, so we have taken the manual process of sieve shaking. We are also having the mechanical sieve shaker in our laboratory, which we will be showing you later on, and that we can easily do later on. Okay, so obviously the mechanical sieve shaker will give us the better result in terms of the separation of the aggregates. Here it is the mechanical sieve shaker. Now we will be going for the exact stress procedure, which will be mostly done by Ajitesh Bhattacharya. Obviously we have marked the different numbers in the table. So first of all, it is written as 20 to 16, then 16 to 12.5 in this way. Obviously they are having the different kind of meanings. The one 20 to 16 means the 20 passing and 16 retaining in the aggregate. So 20 mm sieve passing and 16 mm sieve retaining is your 20 to 16. Whatever may be the aggregate which you have kept will be passing through 20 mm sieve and have retained on the 16 mm sieve. Next up is your 16 mm passing, 12.5 mm retained, 12.5 passing, 10 retained, and 10 passing, 6.3 retained. So these are all the sizes, and now we will be taking the thickness gauge. Obviously for 20 to 16, as we have said earlier, this opening should be used for the aggregates. Some of the aggregates will be passing, they are known as the flaky materials, and some of them will be retained, they are known as the elongated they are known as the non-flaky materials. Okay, so obviously we will be taking the flaky materials for the construction, non-flaky materials for the construction purpose, because flaky materials are likely to be crushed when the heavy vehicle loads will be moving. Okay, so we will take only non-flaky materials. Okay, now this is your manual testing. Obviously it will take some time, and obviously Mr. Bhattacharya has done an exceptional good job. So some of the aggregates are passing and some of them are retained. These retained aggregates, or in other words non-flaky aggregates, are kept in this particular side, and with the help of these non-flaky materials we will be doing the laboratory testing later on, okay, of the for the determination of the elongation index. Okay, so obviously for the time being we are showing you only a few aggregates, but the entire process will be done later on. Obviously they are not shown in the video, as the video will become very lengthy in that particular case. So here some of the aggregates are being retained, which are again kept inside in this side. Okay, this aggregate is coming from the 16 mm passing and 12.5 mm retaining. And again for all the sieves we will have to take all the materials and we'll need to do the similar kind of testing. Okay, now what you can see is that after the aggregates are either passing or retained, they are kept in two different areas. Okay, why? Because we will need to take the weight of them differently. So as a result, we can easily get the value of the flaky materials. Okay, the value of the weight of the flaky materials, and from there we can easily determine the flakiness index value. Okay, and again remember the flaky materials are likely to be broken. So entire testing has been done. So in this way we have done the test. So as shown, this is your 12.5 passing, 10 retaining. There some of them are retained on the gauge and some of them are passing on the gauge. So again we will be taking the materials which are passed through that particular gauge, and now we will be taking the weight. Okay, now this weight will be done, will be taken or noted for the calculation purpose. The manuals will be sent to you. Obviously the calculations are not being shown over here for the time constraint, and now we will be doing the elongation index test. That will be done with the help of the length gauge. Remember, in case of the elongation index value, we will take the greatest dimension, that is the length of the aggregate. In case of the flakiness index, we were taking the thickness of the aggregates. Now for the elongation index, we will take the length of the aggregates, and if the length of the aggregate are greater than the 1.8 multiplied by the mean value of the sieve sizes, as one sieve size has been shown, you can see over here. So the average value is 18. So average of 20 and 16 is 18. It will multiply by 1.8, which will give us the calculated value as 32.4. So if the aggregate's length is more than 32.4 millimeter, then we will be going for the elongation index calculation. Okay, so again the manual process will begin. Some of the aggregates obviously will be passing and some of them will be retained. Remember, the materials which will be retained are very lengthy and they are generally not taken for the purpose of construction. Why? Because they do not provide us good interlocking facility. Okay, so with the help of this process, obviously we will be able to separate the elongated materials. Okay, so this is again your manual testing and it will take a lot of time. So for the time being, we will be showing you only a few samples which will be either passing or retained through the sieve, and obviously Mr. Bhattacharya is doing his job, and in the background we have done the entire process, and here it is. This is the materials which are retained, and this is the materials which are passed through that particular openings, and this is the material which are retained. Now this material retained should be taken for the calculation of the elongation index value, and we will need to take the weight of them separately. Obviously, all the calculations are not shown over here. We will be sending you the manuals which are required for the calculation, and obviously with the help of that you can easily get the values. So this is it for today. Thank you.